So this is the circuit we're going to be working with today. And if I go to get the link for you, I'm not going to make you rebuild this because not only would it take time, it's also quite confusing to try and set up. So if I send you this link on the chat, everyone should be able to open up this link, go to Tinkercad, and you should have the circuit without any code in outside of the very basic stuff that comes default. So if everyone could do that and confirm that for me. Okay, so whilst we're waiting for everyone to open up the code, I will talk you through quickly what this circuit is. So for those of you who were there for last Thursday session, some of this should look familiar. Basically what we've got is we've got a H-bridge set up, connected to two motors. This motor is connected to pins 10 and 9. This motor here is connected to pins 8 and 7. So for those who don't understand how H-bridges work, and also to just have a quick refresher, if you were to connect either of these motors directly into pins and into a digital pin and turn them on and off, you could only get them to go in one direction. If you wanted them to change directions, you would have to swap the negative and positive input on the motor. What a H-bridge allows us to do is have two digital pins connected to each motor, and whether you set the one as off and on, and depending on what order you've got them set up, it will change the direction. So for example, if we had pins, if a pin 11 set to high and pin 10 set to low, the motor will spin in one direction. If we have 11 set to low and 10 set to high, the motor will spin in the other direction. Do we have any questions about that?
Sounds good.
Yeah, sounds good. Okay, and then what we've got on this
so the switches are open and closing, pretty much.
Sorry.
So switches are open and
It's
closing.
basically like it's like swapping switches. Yeah.
Yeah.
But it does it digitally rather than having to have a mechanical switch.
Yeah.
And then the other thing we've got up here is just a simple IR receiver plugged into 5 volts, plugged into the ground, and then plugged into pin number 11. So what this IR receiver does is it allows us to read things that are being sent from this IR remote over here. So that's what we're going to be aiming to try and use to control these motors. Have we got any questions so far? Perfect. No. All right. Please don't hesitate to ask questions. I know I keep rambling on about not hesitating to ask questions, but the whole point of doing these live is so that you guys can ask any queries you have, no matter how ridiculous or stupid they may sound. Okay, so let's get started. So the main thing I'd like to focus on in today's session is we've talked about variables, we've talked about loops, we've talked about, what else have we talked about? Let's have a look at our old code. We've talked about if functions, and we've talked about serial, which is quite important for Arduino.
And serial print.
Yeah, serial begin, we've got serial print lines, etc., etc. So we know how to control digital pins. We know how to decide what outputs happen depending on certain statuses. So if a button is pressed, etc., etc. We know how to use delays and why they're important in Tinkercad specifically. Everyone's familiar with variables. If there's anything that I'm talking about here that you're not 100% set on, please ask and we can quickly delve back into it, because these are all important things that we're still going to be using today.
Oh, Ryan, yeah. Could you briefly go over what serial and delay is?
Yeah, perfect. So what serial does is this Arduino is plugged into a USB port on your computer.
Yeah.
What that does is it provides power, but you can also transfer information. But initially, all it does is power. So to open up a channel between your computer and the Arduino, you use the USB cable, because you've already got that plugged in, and you open a serial bus. You open a serial begin, and the default is 9600. That is just Arduino specific. On different boards, it might be different. You can also use different channels if you're trying to use different serial buses at the same time. But the basic is when you're outputting stuff and you've only got one bus open, you open a channel at 9600. What that means is that when you serial print, it will output to whatever serial monitor you're using on your computer, which by default with Arduino is 9600. It will know exactly where to send the information, and that's where all your serial prints and your serial print lines will be outputted to.
Okay.
Does that make sense?
Yeah.
Okay. And what delays do is, because of the way code works, is that the computer just runs line by line as quickly as it can. So as quickly as it can do the process, it does it. But sometimes you want to wait, because otherwise it's going to keep doing the same process, or you need a bit of a gap between certain processes. So what we enter in C++ or on Arduino is delays.
Okay.
And what the delay is, it's a function that intakes whatever number you put and waits that amount of milliseconds before moving on to the next line of code.
All right.
Cool.
Okay. So 9,900. What's the number? 900.
9600.
Oh, 9,600. That's a. Am I saying it right? Is that a bus?
Yeah, it's a default. It's a different. So USB stands for Universal Serial Bus.
Oh.
And what you're doing with serial begin is you're opening a channel through the USB on like you're opening a link.
It's 9,600 bits per second.
Yeah, it's a board, right?
So it's how fast the bus sends things. So, and you can set the value. So it's 9,600 individual bits per second is allowed to be sent between the universal serial bus, the USB plug, to Arduino.
Okay. All right.
So yeah.
Cool. Does that make sense?
Yeah.
Cool.
Okay. Is there any bit of this code that people are looking at right now that that they can't figure out why it's there or what it does? Look at it like if you would have to explain it to someone.
Why do we print the status again?
Sorry?
The status. When we on the serial monitor, we
Yeah.
output a status. What's the reason? It's just to tell us that it's outputting green and red.
Yeah, so, and the way we have it set is so that at the beginning, as soon as the button is pressed, it will print serial prints. It will print status. But it will print it as a character rather than a line. It won't take up a whole line, so it means that the next thing you print will go straight after it. So it prints status every time, and then, whether it's red or green, it prints that afterwards next to it, and then it makes a new line, which is why we have print line here. We could do status red and status green here and remove it here and just make one big print every time that the status, but there we would be repeating code. So we're repeating this bit, and with programming you want to use you want to repeat lines as little as possible. So all of this, the only thing that this saves us is from writing status twice, because we could easily just have gotten rid of this and put status red and status green in those prints, and it would do the exact same thing. So in the idea of having repeated code as little as possible, today we're going to be focusing on functions. What a function is a block of code that you can refer to at any time, and it will run that block of code. So let's make a function, shall we? So the way these motors work is we've got them connected to, sorry, give me a second to just move around on my screens. We've got this motor connected to pins 7 and 8, right? No, we don't. We have this motor connected to pins 10 and 9. Now we have this motor connected to pins 8 and 7. So if we set one of those pins to high, one of those pins to low, it will go one way. If we set one of those pins to low and the other one to high, then it will go the other way. So let's just try it quickly, just so that we're on the same page. So we need to set up our pins because we're using Arduino. So obviously these are outputs because we're outputting a value to the motor. We're outputting high or low. So we just need to make sure that we put output 7, 8, 9, and 10 as outputs. I hate copy and pasting on this because it just the indentation doesn't work very well. So this is just telling our Arduino what is happening in those pins that it's connected to. So saying that pins 7, 8, and 9, which are the ones that are connected to our motors, are outputs. So now, if we go in our program, in our loop, and we were to simply put in digital write with a capital W, because camel case, 7 high, semicolon, and digital write 8, semicolon. So that just means that the one always has to be high and the other one has to be low for the motor to turn on, for the motor to move. So you're trying to create a complete circuit. But what this H-bridge does is it allows us to decide which way the circuit is going and therefore which way the motor is turning. So if we start simulation now, what have I done? We will get loads of errors. Pin mode, output, output. Just that. Pin mode.
You got the right pins?
Are they the right pins to send them those?
7, 8, 9, 10. They're all outputs. Let me just refresh. Oh, that's not saved very well. Okay. Well, anyways, I actually can't be writing on this version of it. So give me a second to open a copy. Okay, so if you see, can you guys see, is this visible for everyone?
Yeah, well, that's disappointing. No, it didn't do anything.
No, did you expect it to just explode?
Yeah, that'd be great.
So as you can see, our one motor that's plugged into 7 and 8 is now turning forwards. So we need to make sure that the comment our code. So for those who don't remember, comment is done by // and it lets you annotate your code without affecting the way it's run. Setting.
How come we're adding a delay?
Just because it helps run on Tinkercad pure. That's the only reason, really.
Okay.
Here we have. I'm not going to comment this code too much because we're going to be. This is just making sure everyone's familiar. So once you've got one of your motors or both of your motors moving forward, can I please see hands raised in the chat? If you, for any reason, cannot get to that, please ask away. If we put 9 as high, I should have this wide up so that it's always the lower number for each motor that's that needs to be high for forwards. So the first motor is 7 and 8, 7 is high for forwards. The second motor is 9 and 10, 9 is high for forwards. Does that make sense with everyone?
Mm-hmm.
Please do not be afraid to ask any question if you have any trouble at all. So
before, how come you had digital write 13?
That's just the default for when you create a circuit on Tinkercad. Like that bit is the default code that comes up as an example.
Right.
So, if we were to write this code, so the way that this code is going to work is we're going to be receiving values from this remote control. And then when we receive a value from this remote control, we will use that to translate to the motors going forwards, backwards, left or right, or turning off. So we imagine that this is motors for each of these is the back wheels of a car. So this is the left wheel and this is the right wheel. Does that make sense to everyone? So if both are going forwards, the vehicle will go forwards. If both are going back, the vehicle will go back. And if this one is turning and this one isn't, the vehicle will turn left. If this one is turning and this one isn't, the vehicle will turn right. Is everyone happy with that?
Yep.
Okay. So if we were to write out every time we want the vehicle to go forward, backwards, and have to write this, for example, if every time we wanted the vehicle to go forwards and we had to type all of this out every single time, that would be very inefficient, wouldn't it? So instead, what we're going to do is we're going to make a function, and our function is going to be called forward. But our function, when you create a function, is, so technically, setup is a function. Setup is a function that will always run. And the reason why it's void is because it doesn't return a value. Same with loop. Loop is your main function that will always run. And it will loop because that's the way that it works with Arduino, but there is no returning value. So if, for example, we were doing a function that calculated something, so we could make a function called int cal addition, right? If I could spell, that would help. And intake two values. So what the brackets does is it tells you what's being passed on. So we're getting two values x and y, and then in here we make return x plus y. So obviously this is very basic and you wouldn't really need to do this because it's very, you could do this quicker and more efficiently. But the idea is that now in my code, every time I write addition with brackets and put in two numbers or two variables, if you're using variables, what it will do is it will save, and then I can put a new, I probably want to create I want to create a variable called answer. And then what I can do is I can save addition into answer. So what this will do now is the code will get to this line and it will see that it needs to change the value of answer to this. So it sees that this is our function called addition. So it goes up to here. It sees that we have a function called addition that takes two values, x and y. So now it will assign 12 to x and 82 to y. And then it will run the code and it will return, the value that it will return is x plus y. So it will add both of the numbers that have been passed through. And then what it will do is it will take that answer as the return value for this function and it will save it in answer. That's quite a confusing thing to get your head around if you've never worked with functions.
So it sets x and y as those two numbers.
Yes.
Yeah.
To reiterate from last week, you see how the top function void setup has the word void and void loop has void in it, but the function addition has the word int instead of void. And you'll notice that all the ones that say void, they don't have a return statement. And you'll notice in code or in most languages, if you have a function that doesn't have the word void in it, it will always ask you to return something. So what we do is we just void and tell the function, by the way, you don't need to return anything, just ignore that, and then you can get away with not writing return at the end. Because functions main aim is to do some math or do whatever and return something to you unless you tell it otherwise, which is why we use void.
So obviously it can return all of this, but it can also, we could do return times 10, and then so it will run whatever code we have in these brackets, whether it's for the return or not. We just need the return at the end because this is an integer function, so it's returning an integer. We don't need a return for these because we have void at the beginning, like Ali said, so the code knows not to expect an answer. What we could do is we could create 2 new variables in here, int a, b, and we could do a is equal to 10x, 10 times x, and b is equal to 10 times y. And then what we can do is we can return a plus b. So now what that will do is it won't return the same numbers added, it will return 10 times each number added together. So it's just a different way of using a function. Does that bring up any questions with anyone at all?
Okay, that's good.
Okay, everyone's managed to wrap their heads around that a little bit. So the function we're going to be creating today isn't going to be returning any variables because the function we're going to be using is to control the motors. What we're going to be creating is a void function because there's no return value, and we're going to make one called forward. Whenever we run this code,
just to annoy you, don't forget to remove answer in addition. Because
perfect. All right, so every time now in our main loop code we write forward, it will run whatever code we have in here. I think I unmuted myself. I muted myself by accident. So our function forward has our code in it, which is this code is to go forwards. So now, every time in our main loop we write forwards, we record this function. What the code will do is it will read this line. It will say, okay, I need to run the forward function. It will go up here. It will run whatever lines of codes are in this bracket, in which case now it's to go forwards on both motors. And then it will go back, it'll run forwards on both motors, and then it will continue from where it left off. So now, if we press simulate, even though in our main loop we're not telling the motors to do anything specifically, because we're recalling the function forwards, it runs the forward function and has both motors going forwards. So can everyone get to a point where they've got this working, please?
Mm-hmm.
If you've got any questions or anything that doesn't work for any reason, please ask away.
Does it matter if the function comes before or after the loop in the code?
It doesn't. It's just a principle, like ethics, programming ethics, to put functions at the beginning of a program.
So that other people can recall it from there.
Well, it's just so that you know when you're reading, because if you put it at the bottom, you have to scroll all the way to the bottom through all the code. Whereas if you're reading code and you're reading the functions first, and then you're reading the main code, when the code uses those functions, you already know what they're doing.
Yeah, it's a top-down approach. So you write all the little pieces that you need first, and then you put the big triangle, the big, using the little blocks that you've got at the start, because you don't build a house without getting your bricks out first, do you? So you make all the little bricks,
So
and then you lay out
functions first, then you use them. Okay.
I mean, if any of you are interested in code, I know embedded C works the other way around, and it's somewhat crazy, but this is the way forward. You build your bricks, you lay out all your bricks in the right path, in like the right shape, and then you build the house.
Does the way you set up your code, does it affect the way you set up the code?
Sorry, what do you mean by the way you set up the code?
So like organization, if you don't use certain code in different places, does it matter?
No, it doesn't technically. You could, for example, have it's all like an ease of use for people to read, and it's also just easier for you to spot your mistakes.
Okay.
You could technically have this like this, but it's not only not as appealing, but it's also more confusing, and it's also harder for you to spot your like, for example, if you're missing a semicolon somewhere, if you're missing a squiggly bracket. I mean, earlier on when I was just testing this before the final program, the amount of times that there was literally just a semicolon work not missing that broke everything, or like one bracket missing, or a squiggly bracket in the wrong place. Like this is the main reason why, and it also just makes it easier for when other people are working on your code with you.
It's literally just easier. Like, why would you not put something in like numerical order 7, 8, 9, 10, 7, 8, 9, 10? Why? There's no point in writing 7, 10, 8, 9. It's just gonna slow you down efficiently.
It's like writing English without paragraphs. It's a pain to read.
Yes, pretty much. Quite literally, is simpler as well.
That's I like that metaphor a lot, actually. So, seeing as everyone's managed to get this working, can I get everyone to try and create their own backward function? So you should be familiar with what kind of code you need to put in there, and you should have it so that when you call the backward function, both motors are going at negative 143 RPM. So I'm not going to put my code for it in yet, but this one's quite straightforward for people to get. So if you've already managed to do it, can people start taking a stab at doing, we're going to do a left and a right one as well. So have a go. So if you think about it, when we're going left and right, we'll have one motor off and the other one going, one motor turned off and the other one going forward. Whilst you're sharing your screen, can you go back to the code quickly, just to show everyone? So can we all spot the way that he managed to turn the motors off when they weren't being used? Because I didn't mention that, I was just trying to see if you guys could figure that out. It's by having them both on low. So if you want the motor that's connected to 7 and 8 turned off, you put both 7 and 8 to low. If you want the motor connected to 9 and 10 turned off, you connect both. You put both as low. Does that make sense to everyone?
Are gears more accurate? Are they meant to be accurate?
Say that again.
Are gears meant to be accurate?
Not in this case. In this case, it's to increase the torque of the puny motor. But if you have, for instance, a servo, which is a motor, a series of gears and some control circuitry, the gears can then potentially make it more accurate. But again, it's more down to the control circuitry. The gears are simply there to manipulate the output speed and the output torque of the motor itself.
Alright. If there's ever any time you guys can't see or want to see something clearer, just ask. So now we've got functions to turn the hypothetical imaginary vehicle forwards, backwards, right, and left. So everyone got that? Do I need to give anyone a couple more minutes to just finish it up? No? Okay, I think we're right. So now, just to check it, if everyone could just copy what we've got down here and try each of their functions with a delay of about 1,000. So I'll do forward. Do backwards. Do right. And do left. So now if we start simulation, we should see it go forwards, then backwards, then right, and then left. Forwards, backwards, right, and then left. Just make sure you've got yours doing that, and as soon as you can get it to do that, I'd love to see some raised hands in teams. Alright, so now, what do we want to do with this? So obviously, we could write a code that if we knew, for example, how long the robot needed to go forwards and backwards, but there's no fun in that. So there's different ways we can control it. And I think the coolest way for us to control it that we can really try in this environment of Tinkercad is using this IR remote. So, is everyone ready to jump straight into the IRO remote, or do we want to try and control it with our keyboard first? Because we can control it with our keyboard using serial begin, using a serial like reads, so it can read.
Can we try use our keyboard first?
Yeah, perfect. Okay, so let me just get it working. So can anyone remind me what we need to do at the very beginning of the code when we're using any kind of text input and output from the Arduino? Yeah, exactly, Abdulaziz. It's serial begin. So I might just copy it off here. So this just opens up the communication between the Arduino and okay, so when we're doing serial print, it outputs, but to understand what is being inputted, we need to do serial dot read. And what that's going to do is that's going to read whatever we're typing on the keyboard. So is everyone comfortable with WASD as a control method? Is everyone using a QWERTY keyboard where that makes sense?
Mm-hmm.
So W would be forward, S would be backwards, D would be right, and A would be left. Yeah, everyone comfortable with that?
Okay.
Any gamers, PC gamers in the chat?
Probably
Big up
PC gamers.
You
PC
should be asking if
Master
there's
Race.
any non-gamers.
Yeah.
So obviously, remember how last time we had a variable called button status, and that's what we use to keep track of the button status. This time we're going to have a value called input, and actually, can that be an integer? I don't think it can be. Let me just double check for 1 second. Let's just keep it as 0, as we usually do. So if we put, obviously we've got all these functions now, so they're taking up a lot of score space because we're so zoomed in. But if we put input equal to serial read, what that will do is every time we put in something in, we type something on our keyboard into the serial, it will save that into the input variable. Is everyone okay with that so far?
Mm-hmm.
Okay, I'm just gonna do some fancy. So in coding, you get a lot of errors. Obviously, when you're making programs for yourself, those are fine because you can fix the problem or you can go back and know how to fix it. But when you're doing, when you're giving out or using programs that are going to be, if you're making programs that will be used publicly or by other people, you want there to be as little errors as possible, and for the errors to be caught if they happen so that the user doesn't have to do anything on their side. So what I'm going to do here is I'm going to do if serial dot available is greater than 0. So if something is actually input as expected, then run this code so that we don't have any errors coming through, whether it's something being inputted wrong or something not being inputted at all. It just saves the likelihood for errors to happen. So if we now do, for example, serial dot. Also, just keep in mind that I was planning on using the remote first. Obviously, this should work, but if there is any issues, I will just be fixing them on the go. Serial should be with a capital letter always on C. And we do serial print line. just so we can keep track of what we're printing. Yeah, what's up?
I was just going to say, while, if anyone wonders, the difference between print and print ln is the fact that it appears on a new line rather than just next to each other, which is all I was going to say. Just thought I'd let everybody know.
Let's just try. Just give me a second. Change your input to a character. So obviously variables can have different types of variables. You can have a number, you can have a character, you can have text. What we're going to be using is, because we're only going to be putting one character at a time, we're going to be saving it as a character. So it's going to be one letter. You've also got, you can save in arrays, which is like an Excel spreadsheet basically of data. You can save in a Boolean, so it's a yes or no. You can save in different types of numbers, so a double, a float, an integer, a long number. And then you've got strings, which is just any line of text.
Just to confuse everyone, the character or a string, like for example, the character 1 is different to the integer 1.
Yeah, so when you see when we were printing out, oh, that's why, because I didn't actually put input in here.
Stop the simulation.
Yeah, remember when we were printing out red and green on the other program? So if I go here, when we're printing out red and green, we have these quotation marks. Anything between quotation marks is a string. So when you put string and you save a string as 1, that is not the number 1 as a value. That is text that says 1 in it. That's very confusing, isn't it? Has everyone got that?
So it's not actually, it's just text.
Yeah.
It's just like,
so character or string is just text.
Okay.
But that it can include numbers, obviously.
so you can't add string 1 and string 3 to each other because they're both not numbers. It's not a calculator. It's just you writing it down on a bit of paper.
Okay, so I've got it working. So now whenever I type a character, it returns it to me. Can everyone get that working? Has everyone got that? When you do, can you please put your hand up? So now, obviously, the reason why we're inputting characters is not to have it come back to us, but it's to control the robot. So we could do if W is pressed, go forward. Else if A is pressed, go back. Else if S is pressed, go backwards, etc., etc. But that's way too extra for what we need to do. So we can use this function in programming, which has different names in different languages, but in C++ it's switch.
Sweet.
What switch does is you give it a variable or an integer or a value, right? What we're going to be giving it is our input. Then what it does is you can give it different cases, so you can say case W. So what this says is if it's W, run this little bit of code. So what we're going to do if it's W, we're going to go forward. We're going to give it the brackets and semicolon, and then for the switch command to know that this case is finished, after every case, you need to put break, semicolon. So now in theory, if I get this lined up again, if I haven't messed anything up, yes I have, I've added one too many of these. No, I haven't. Switch. Oh, okay, I need this to close here. No, I don't. I want the if to close here. I want the switch to close there. Loop. Switch. If. Loop. Oh, it's because I've got, maybe I don't need to put W, maybe. Oh, I don't need to put it. yet. No, I do need to put it in the set. Does it only work with integers?
Yeah, I'm assuming. Because something.
We can get around that very soon.
We can, bear with. Switch.
That's fine. No, it only works with numbers, which is fine, because you know what we can do? In this if, we can do...
you should be able to do it with strings instead of characters, even though it's a single character.
Really?
Yeah.
Alright, let's just try string.
Even though it's a single character, I think.
Is string in C++ like everything else where it's capitals?
Yeah, I believe so. Where?
No, it's not.
Guess not. I was wrong.
String. Sorry. Oh, so yeah, when you get to obviously it's. I think it is with capital. String input. Let me not give it a value, so that could be confusing. Void loop.
You can go back to it being a character and try single quotations. I could be wrong. But this could suddenly become a big problem.
No, if it's not, I've got a very easy workaround.
Yeah, send it back to a character and then use single quotations and not speech. Safe.
Oh. So now if I clear and I send it a W, it goes forward. So okay, perfect. So note that when you're using char, you want to use single quotation marks, not double. Has everyone got that and understood what the problem was there? Did anyone not understand what the problem was?
Ask me why that's the solution. I haven't got a clue. I just know that.
Well, it's just to do with how Arduino reads characters.
It understands characters as integers, in which cases it's a weird mess. That's why I use the non.
Okay. So, can everyone see what we've got going on here? So what it does is our code, if something's being inputted, it will read that, save it in inputs. It will print out the inputs just so that we can see it and keep track of it. It will wait a second because Tinkercad, and then what it will do is it will check, is input W? If it is, it'll go forward and then stop this case, and then move on to the next, move on to whatever is next, which is nothing, so it will start the loop again. So if we do another case,
sorry.
So, no, go on.
Do we need to put in the string instead of the character?
No, don't keep it as a character. That was just us trying something. So A, we want A to be turning left.
What did you say break does?
So break. So you see how in this switch we have multiple different cases. So case W, it will go forward. It could do loads of other things as well. So we can have plenty of lines of code here. But break says, okay, this is the end of this case. Move on from the switch function. So it's not going to move on to the next case. It's going to stop the switch function and go on to the next line of code.
It's because, when you use an if, we put it in the loop, so it always constantly checks if that thing is true. When you go into a case, it goes, if case W, and then unless you break it, it will always be case W is true because you've already inputted it now, and that's it. So it'll get itself permanently stuck inside case W unless you tell it, okay, once you've done that, you can break off of this case now and go back to the end of the loop. So you have to put a break in a case, whereas in ifs you don't, because it will constantly go, is it this? Is it this? Is it this? Is it this? Whereas case will go, okay, it's this now, and then stop checking. So you need to break out of the case, otherwise you get stuck again.
Okay, thanks.
Did that make sense?
Yeah, it did, thank you.
So can everyone see what I'm doing and follow along? If there's ever anything that you're writing and you're doubtful, or you're like, actually, I could do with a bit more of an explanation, please ask away. I don't want backwards, that one. Right. So in theory now, if I run this code and I press W, should be going forward. After a second, I might get rid of that delay and move it later. If I press A, should be going right. No, left. If I press S, we should be going backwards. If I press D, should be going right. Perfect. Look at us. So we've got all this. I think it's pretty exciting. But I think it would be even more exciting if we're using a virtual remote control. Even though it's less exciting than a real remote control. Probably less exciting than your keyboard. But it's still a really good thing to learn. So, in default Arduino, there isn't any special coding that helps you use IR remotes. So what this remote does is it uses infrared to communicate and send signals. And what this is, it's an IR receiver. So it's a little like receiver that will take in the IR light and understand what is being sent. Does everyone understand how that works? That's what you'll use for your TV remotes, more than anything, like air conditioning remotes and stuff like that.
Okay.
Everyone familiar with the idea? So how do we get this little IR receiver to tell the Arduino what is being pressed? Well, there isn't really code for that. That like just works straight away. So we've got to import a library. A library is an external, external load of code that's got functions and different variables and stuff that you can use. That doesn't come base. So you know how here we can use char, and it knows that that's a character. We can use void, and it knows that it's not gonna have to return something. We can use serial.print, and it knows what to do. You can download libraries and use libraries for other things such as IR remotes that have things like that make your life easier. So if everyone presses at the top, there's a button between the download code and the debug button called libraries. And if you press you should see the second one from the top is IR remote. If you include IR remotes, you should see this line of code at the very top. Now what this does is it tells your code to include everything in the library irremote.h when it's running the code. So it will be familiar with all the context and syntax and functions that are in irremote.h, which is what we're going to be using to control the motors with the remote control. So everyone understood what that means?
So there's an existing library, and that tells.
And that has code that helps us control the IR, use the IR receiver directly.
Yeah.
So as we now have included the IR remote, we can now use IR specific code. So you know how we have to do the setup for the pins? We have to do the same for the pin that uses the IR remote. But this doesn't go in setup because it's separate, because our main code doesn't understand it. So we need to initiate it, and we used that with a line of code that's IR receive, but not spelled the whole way. So that's initiating so the IR receiver, and it's going to be IR. I'm not going to there isn't that much logic to why things are spelled the way they are, but it's going to be receiving from pin number 11. Yeah. And then just again for avoiding any problems, we just need you just put it results. That's just so that it knows to decode whatever results it gets from the IR receiver properly. A lot of the stuff from libraries, you'd want to ask why it's saved as this and this, or why it's called that. There isn't that much logic to it. It's just the way it is. Now, we have to also enable the receiving in the actual code. So like we've got serial begin, we have IR receive enable IR in. And that knows that from our IR receiving pin 11, which is this, sort of referring back to this, we need to enable IR inputs. Obviously, the syntax is different. Does everyone understand what we're doing with these lines of code? With stuff like this, you will always have the library open to know what you're using. So you don't have to like remember these lines off the top of your head, but please ask what things are doing.
So in the IR enable, are we enabling the pin for it?
No, the pin is already enabled with IR receive.
Okay.
So this is saying our IR receiving pin is number 11, and here IR receiving, which is our pin number 11, enable IR input. So our code now knows that our IR input is going to be coming from this, which is set to pin 11.
Okay.
Why am I struggling so much to speak? Enable IR input from so whilst everyone's writing that, I'm just going to comment my stuff properly because we're keeping this code now. IR receive. Once you've done this, can you please make sure you put your hand up? Okay. So now that we've got our IR receiver, we can talk to it. We now have to actually understand it and get values from it. So the same way that for serial print, we have this to make sure that we have things run properly. For IR, we're going to have an if. Let me just delete this. Actually, I'll keep it and I'll delete it later. We're going to do if. Now, this is stuff that you will literally just copy paste every time because there's no point remembering it. It's always the same. It's just error prevention. Results. So this is referring back to the results that we were talking about earlier. Don't worry about typing this out. I'm going to be
wow.
If anything is received, then we will unsign int value. So you know how we set up char at the beginning? We set up our char input. When you create a variable that you intend to keep, you always do it at the beginning. So I will actually change this, but you can, this is just to show you, you can create a variable that's going to be temporary. That, for example, this will only be saved in each loop. Every time it's run, it's going to be different. It's not going to save it throughout the loop. Whereas char, if we loop it and it stays the same and we don't change it, it will remember what it was before. So results. Result dot value. So what this is doing is that it's getting, so this is making sure it's waiting to see if we receive a signal from IR and what its result is and storing its result. So we're saving its result. So whatever is being sent. So if we're getting sent up, it will save the code that stands for up. Then we're saving an integer called value as whatever was sent. And then just to be safe again, so this is like what we're doing here with input serial read. We're doing value equals results. Is anyone lost with that? Because you can very easily get lost with this. Please say so.
I'm a little confused.
Okay. So when we initiate our IR receiver, we tell it to decode the results from the IR receiver in results. So what that does is now we have an if function. What this if function does is it won't run until something is received by the IR receiver. So this IR receiver, which is saved to pin 11, decodes something, and it will save that as results.
Okay.
But the way that results is saved is not exactly like a number. So we have to make sure that when we save it as results.value. So it gives us the value of what was sent. So when you press up on this, let me show you because I've got it running now. I can comment this out for now. Okay, so if I look at my serial monitor now,
Decode and do code are two different things.
Yes, they're very different things. I do want it to do the code. So now, if I go to my serial monitor, I clear it. What it does is it will wait for something to be received, save that in results, and then save the value of that result in a variable that we're just creating called value. So if I press up, it gives us this code, which is the code for up on this remote. If I press, the reason why it's repeating is because this is looping and the value doesn't change. But if I press, oh no, do you know why the reason why it's looping? The reason why it's saying the same thing is because I haven't put down a line of code. So every time we run the loop, before we go to the next loop, or before we're ready to receive another variable, we want to do .resume. So we want it to start listening to the IR thing, to the IR remote again. So once it receives a value, it stops until you ask it to start again. So now, if I start simulation, and I clear, if I press up, it will press up. If I press down, it gives me the value for down. If I press right, it gives me the value for right. If I press down, left, it gives me the value for left. Has everyone got that?
Okay.
Does everyone understand what's going on here? This is slightly more complicated.
I think I understand.
Do you need any explanation or anything?
Any questions at all? This is getting to definitely more advanced Arduino stuff, hence why I wanted to do it if we had the time.
I kind of get it.
Yeah? Not a single question out of anyone here? All right.
What did you say resume does again?
So resume. So when it receives a variable, once it receives an answer from the IR remote, it stops asking. Because obviously with IR, sometimes the message like is in the air for longer or whatever. It just stops listening. So what resume does is it tells the IR receiver to start waiting for a new value. Because otherwise it's not going to listen for anything anymore.
Oh, okay.
It's like as soon as it hears one, it goes to sleep, and this is you saying, "All right, wake up. We want to wait. We're waiting for something new now."
Okay.
All right. So now we've got a value, a variable called value that has are IR inputs. And we can use the exact same switch statement, but instead of using input, we're going to be using value. And instead of letters, what we're going to be getting is the code for all these buttons. So the code for up was, let me just double check on my notes. Yeah, it was I've done them in order. It was 2065. The code for down was 4335. No, sorry, down is S. So we want 4335. The code for left was 8415. Don't worry, I've saved these notes, which is why. So the way I figured this out was I got it to print whatever I was typing, and I took a note. So when I press up, it prints out 20655. So that's what the value of up for that remote is. And then for
there's a random X on line 65.
Yeah, cheers. Then for right, we want to do 24735. Does everyone understand what these numbers are?
These are forward, back, left, right. Except for the keyboard, it's the control thing. Controller, okay.
So can everyone try and get this working? So now, if I launch the code, oh, I've got I've got this that I need to get rid of. If and I turn on my serial monitor and I clear it. When I press up, why isn't it going forward? Well, down. Maybe because of this time. Switch value. Let's get rid of this delay. Have I got everything correctly?
Hold the button, maybe.
Sorry?
Hold the button instead of pressing it
no,
once.
because if you hold it, it gives you a cumulative value.
Ah.
It gives you like the max. So if you hold any of the buttons, it will always give you 6,
Well,
5.
back works.
Oh, what about forward now? What if I go right?
Left and right.
Maybe it's just by
That
forward.
works. Yeah, so it's just
Just
forward.
have I got it as the right number? Oh, it's 655. Sorry. Not 5H.
H.
Sorry, we all know 5 is spelled with a H. So now, forward, backwards, left, well, right, left. Oh, I'm well happy with that. I mean, this is exactly the same code that I had working before, but that didn't work on Tuesday, so that same situation didn't work on Tuesday, so I was fully expecting this not to work. So, can everyone try and get this to work, please?
Okay.
I do have to shoot off at 7:30, so I'll stay for another 5 minutes, but I do have to shoot off. So I think I was going to add a stop function, and then I was going to use the off button as stop and get you guys to figure that out independently. So stop. Homework. But yeah, you could do it as homework if you want. If you want to do it and you want to at me in the chat, if you've got any issues, I'll get back to you as soon as I can. We're not down, so.
I've got to jump off as well. Got a
yeah,
no, me too.
Military thing to get up to, but I can answer questions if anyone does at me in the chat. I just need to be in a different call. 'Tis all. Hope you enjoyed. I'll see you guys in a bit. And
hey, cheers for coming, man, and thanks for your help as always.